All right, so chapter 10. Chapter 10 is three sections. The first section, 10.1, involves proportions. We've done that before, right?
Yeah.
The difference in chapter 10 is that we're dealing with two samples now. So we don't have just one sample, we have two samples. Okay? So, up top is the question we've been asking with one sample inference. With hypothesis tests or with confidence intervals, our question is, does our sample, our p hat or our x bar, is that significantly different from what they are claiming? Okay? So our conclusions always, we reject or fail to reject based on our p-value and our alpha level. Therefore, we have significant evidence or we lack significant evidence, right? That's chapter 8 and 9, right? That's what we've been doing. The difference is chapter 10 asks a different question. Chapter 10 says, are these two samples they've given us significantly different from each other? Okay? So for example, let's say my class took a test. Not this class, but a different class took a test, right? So I have a bunch of scores. And then let's say next door, Mr. Yates took the same test. They got a bunch of different scores. The average score was this over here. The average score was this over here. What we would say is, are the scores significantly different? Now let's say they're different, but significantly means enough to say, hey, there's something going on there, right? One person, the person that got better was significantly different so that there's something to the way they're teaching or the something with the way they're, it was past mere chance of that happening, right? That's how you show that something is going on. Okay? So you're just comparing the samples. That's it. Okay? So our null hypothesis is always going to be the samples are exactly the same. There is no difference. No change, no difference. They equal each other. And then either it's going to be one sample is bigger than the other, or one population is bigger than the other, one population is smaller than the other, or they're just different. Okay? Okay, so back in chapter 4, this is chapter 4 stuff here. Back in chapter 4, we made these guys. We're not going to do that again, but this is the data we're going to be talking about, right? We're going to see a lot of this type of data, right? In chapter 4, we built these things. That's what we did in chapter 4, right? Chapter 10, what we're doing is we're focusing in on this part right here. We're focusing in on this stuff right here. We want to know if group 1 is significantly different than group 2. Okay? Was treatment 1, because hey, if I say group 1 was significantly better than group 2, that means the treatment worked, right? The treatment worked. That's what that means. Even though, so like, sometimes you see a sample and you're like, well, that one's better. Well, yeah, but is it significantly better? That I can say that because of the treatment, the scores were better. I want to be able to directly tie it to the treatment and not just, oh, they just happened to do that, to have that score. Okay? Okay, so that's a lot of the problems we're going to be seeing. We're going to be dealing with this stuff right here. Back when we did this, I'm like, just create it. We'll talk about this part later. Well, now is the time we got to talk about that part. Okay, so our questions are going to be kind of like that. Okay, so here we go. First thing. Two proportion. The first one we have is a two proportion Z confidence interval. Proportions are always Z. Okay, so what this will do is it's going to predict or estimate the difference in the population proportions. Okay, based off the sample, they're going to tell us, they're going to estimate, predict what the difference in the population samples are going to be. Not the sample, population proportions. Okay, so we define parameters for both samples. So we're going to get two samples. So we're going to have two samples we have to define, their populations. Okay? Conditions and assumptions are the same, but we have to check them for both samples now. So instead of having just a T list like this, we're going to have a list like that. We have three lists. We have three columns now. It's the same thing though. It's the same stuff. Okay? Interval will represent the difference. So whatever our interval is, it's going to represent the difference in the proportions. Okay? Two sample inference, chapter 10. If I was going to tell you to study one chapter in the whole book to prepare you for FRQs on the AP test, I would say chapter 10. Because every year there's at least one question about confidence intervals or hypothesis tests, and it's always from chapter 10. Always, always, always. Because they love it. Either confidence intervals or hypothesis tests. It's very, very popular. That one in chapter 11. Chapter 10, chapter 11, guarantee you it's going to be on the AP test. One or two of the six questions will be on one will probably be on chapter 10, one will be on chapter 11. Okay. Test statistic. So the test statistic we use is going to be a little different. It's going to be a little more, there's going to be more stuff in it because we're dealing with two samples. Okay, so this is for two sample Z confidence interval. Now it looks like a beast, but let's look at it a little closer. This part seems like the most difficult, right? This part we're just subtracting p hats, right? Z critical, you guys know how to find that. This part seems like the hardest part, right? This is actually the easiest part. Why is this the easy part? Yeah, this part is given on the formula sheet. You just have two of them now. But aren't they the same? One's for sample 1, one's for sample 2. So it's not too bad. Okay. The conclusion is very similar with a keyword in there, difference. We are blank % confident that the true difference proportion, whatever it is between this and this. Okay. So if two populations have no difference within them, or no significant difference, I should say, what number should be within the interval? No. So if two populations have no significant difference between them, what number should be within the interval?
The same number twice?
No. We only have one interval. I have a number here and a number here. What number in the number line should be within the interval if there is no significant difference? There you go, 0, right? If there's no difference between two things, isn't the difference 0? Yeah, that's what I'm talking about. So if 0 is within, there is no significant difference. We fail to reject. If 0 is not there, then we reject. Okay? And we'll talk more about that when we start doing some examples, okay? Okay, so I don't really want to do this right now. We'll get tested later. I don't want to confuse you with intervals and tests. Let's just focus on intervals right now. Okay. So let's go to this example here. Patients with lower back pain. Patients with lower back pain. Let's jump a little bit.
Are you going to get advice on this? I'm interested. I have lower back pain. You need a better solution.
Okay. Okay, so this was based off of a study done, an experiment done. Okay. You see there's treatments, the word treatment in there, that means experiment, right? So patients with lower back pain are often given non-steroidal anti-inflammatory drugs called NSAIDs, like naproxen to ease their pain. That's usually what doctors give them. Okay. researchers wondered if taking Valium along with that, with naproxen, would affect the pain relief. Okay. To find out, they recruited 112 patients with severe lower back pain and randomly assigned them to one of the treatment groups. Group A, or group number 1, got naproxen and Valium. They got both. The next group got naproxen and placebo, so nothing. So just naproxen. But they gave them the placebo because they just because they didn't want them to know which one was in the placebo group and which one was in the treatment group. Okay? After 1 week, 39 of the 57 subjects who took naproxen and Valium reported reduced lower back pain. Okay? Compared with 43 of 55 subjects in the naproxen and placebo group. So now we have 2 samples, right? So we have to label them. So we're going to do the same exact thing we've been doing before. Label, pick stuff out of it, right? So what we have to do is construct a 99% confidence interval for the difference in the proportion of patients like these who would report reduced lower back pain after taking naproxen and Valium versus just naproxen and a placebo for a week. Okay. So it's proportions, obviously, because this whole thing is proportions, right? We have 2 proportions. What's one proportion that we have?
The proportion of patients that reported reduced lower back pain after taking naproxen and Valium.
Yeah, that's going to be later on. But I'm talking about just in here, stuff we're pulling in here. 39 out of 57, that's one of them, right? And then 43 of 55. Wait, let me move this here.
Randomly assigned 122 or 112.
To 55. Okay. We'll do, and then we can do percentages, or decimals, I should say. 0.39, oops, not 0.39, 39 plus divided by 57.
Hey, you did what? Probably one of those kind of build swag.
Okay. We want a hard test next one? Just pay attention. Come on. All right, so what do I label each of them? Okay, we could do that. We could absolutely do that. That would work. If you do that, you have to explain what 1 is and what 2 is. Okay? So we have to make like a legend or a key. How do we get around that? Well, give them a little more make it a little more obvious. So instead of p hat 1 and p hat 2, we could put naproxen and Valium, or we could just use letters, right? We could say NV for naproxen and Valium, and we could say that as well. Okay. So which one's which? Let's see. 39 was naproxen and Valium, right? So this is p hat NV, and then naproxen and placebo is NP, right? Okay. Now you can put 1 and 2, that's okay. But if you're going to put 1 and 2, then you have to draw a little key here and say 1 is this, 2 is this. Because if I'm grading your paper or someone's grading your paper and you put 1 and 2, first question I'm going to ask is who's 1 and who's 2, right? But NV and NP, they're kind of more in context. Okay. Okay, here we go. Good, that's one thing. What's next? What else can we pull out? No, yeah, N, NV, N, NP. Good. We're going to need that too. There you go. 57, 55, the number in the sample. Good. 99% confidence interval, definitely going to be important. Is there anything else in there we want to? The NV and the NP?
Yeah.
We don't need to label those
No,
since.
I mean, like, do we need like the true proportion of?
Yeah, that when we get started on the interval, we haven't started on the interval yet. When we actually do the 5 steps, definitely that's going to be important. But we haven't started that yet. I'm just trying to pull things out that we know we're going to need later on. Okay. Okay, so now let's start the interval. So we need a population parameter. There's going to be 2, yep. There's going to be a P for NV, and there's going to be a P for NP. Now these are going to be very similar. They're just going to, a couple words are going to be changed, but most likely they're going to be the same thing, right? They always start true proportion. So who are the NV people? True proportion.
Patients are reported to do lower back pain after taking toxin NV.
There you go. True proportion of patients.
The other one
Yes. Who reported? Reduced. Reported. Who reported? Reduced. Lower back pain after taking naproxen and Valium. Okay. Any word that repeats, just use little quotations. So for this guy, I'm going to have true proportion of patients who reported reduced lower back pain after taking naproxen, and this one's going to be placebo and a placebo. Yeah, it looks kind of crazy, but it works. It's accepted.
You can do that.
That's where I learned it from.
Is there any easier way to do it for your test?
Then this?
Yeah.
You could replace the quotations with words. I don't know if that's easier. To me, that's harder.
I can't put like an arrow, like a quotation around the
No.
Start quotation at true and then end it at the positive and put an arrow down and just put M available.
It depends what it looks like. If it's clear what you're doing, then I would say, yeah, that's acceptable.
I mean, yeah,
okay. Yeah, I mean, the only other way is to write every single word instead of the quotations. I mean, that's okay too. Don't get me wrong, that's okay. But this is an acceptable method. Readers on the AP test showed me this method. I didn't know this method before. I didn't make up this method. Readers on the AP test showed me this method and said that's an acceptable way to do it. So I'm like, okay. Okay. Like I said, if it doesn't make sense to you or you don't like it, you don't have to use it. But just make sure it's clear as to what you're doing. Because if I'm kind of like, what is that? That's not good. Okay. Yes. If you miss one, it's okay. Like if there's like 6 words on the second line and you put only 5 or you put 7, is that going to be the end of the world? No. But try to be as close as can. Okay. All right. Okay. So now the next one we're going to do is test statistic. So we have test statistic, which is that long guy. So it's p hat 1 minus p hat 2 or p hat. So which one do we put first, NV or NP? The answer is it doesn't matter as long as it's consistent. And as long as it's consistent and you and you interpret it correctly. Doesn't matter. So this is the thing. On the next test, some of you will have different intervals because you put one instead of the front of the other. It's okay as long as it's consistent. So like let's say we put NV first and NP second. Right? So that means the first one is going to be NV, right? That means I'm going to have an NV here, an NV here, and an NV here. And then an NP here, an NP here, and an NP here. Just be consistent, that's all. It does not matter which one you put first or which one you put second. Just consistency is what they're looking for. Okay. So P hat NV, 1 minus P hat NV over the number in the sample. NV sample had 57 plus P hat NP, 1 minus P hat NP over 55 in that sample?
Yes.
Perfect.
For the test statistic,
Uh-huh.
is it okay to just put like N of NV?
Say it again.
Or do I have to put the 57 in there?
Oh, no, sorry. Yeah, you're right. No, I shouldn't.
Not yet.
Yeah, not yet.
Do calculations, yeah.
Thank you. I should put NV. Thank you, because otherwise it would have been wrong. Yeah, that's going to come in the calculations part. Yep. Okay. Okay. Next one is conditions assumptions. So let me get another sheet. Okay, so let's see. Conditions. And then I'm going to have two check. So I'm going to have a check for NV, and I'm going to have a check for NP. Okay, so sample. Okay, stated. How about the other sample? Okay. Step 2, 10% condition.
So what's big N? 112 or?
Let's see. Well, it all depends on what little n is. So less than 10% of big N, N is less than 10% of big N. So what's the number for little n? For NV? 57 less than 10% of. And then 55 is less than 10% of. Okay, so yeah, it's a good question. Do we have the number for that? No, we just have the number, that 112 number that they gave us, that's just both samples added up. That's not big N. Big N is the overarching one from where did little n, so little n is a sample of big N. So who would that represent? If 57, who are those 57 people? Patients who had back problems, right? They were people who had lower back problems, right? There were 112 people who had severe lower back problems, right? So they chose out of a bigger pile. Who was that bigger pile?
All people with severe lower back.
There you go. People who suffer from severe lower back pain or lower back patients, severe lower back patients, something like that. Back patients, severe lower back patients. Okay. Last one, normality. Since it's a proportion, we're going to use NP is greater than or equal to 10, and N1 minus P greater than or equal to 10. Okay, so we don't have P, so we're going to use P hat. Okay, so N for NV was 55, or 57, sorry, 57 times, what was it, 0.684? 0.684. And then 57 times 1 minus 0.684.
0.31. Oh, no.
So this one for sure, because that one's over 30%, over 50%, and even this one too, right?
Yeah, both of them are.
Okay. 57, let's see, 55 times 0.7 something. 782, thank you. 55 times 0.1 minus 0.7. Top one for sure. Bottom one.
Yeah, barely. Yeah.
Okay.
11.99. I mean, still over 10.
That works. Okay. Done.
Calculation.
Okay. Next is calculations.
I'm pretty sure the calculator can do it.
Oops, I don't want that.
2 sample t-test.
Let's see, select, delete. Let's see. Give me 1 second. Let me. Okay. Calculations. Okay. So we have P hat NV. P hat NV was 0.684 minus negative or 0.7, was it 82? 82, thank you. Plus or minus Z critical. What's Z critical for 99?
2.576.
Okay. So over here you have 0.684 times 1 minus 0.684 over 57 plus 0.782 times 1 minus 0.782 over 55. Okay. All right. So just like, yep, just like every other interval or test, we have a calculator has a shortcut to do that. But this is the work I need to see. That's the only work I need to see because that shows me exactly. From here, I know you're going to use a calculator. Whether you're going to do it by hand. When I mean by hand, I mean, use the calculator functions one at a time instead of using the test. So if you're going to use a regular calculator, you can do this using a regular calculator. It'll take you all of about 3 more minutes.
3?
Yeah, it's not that long.
Really? That looks like a lot. Yeah, but then you copy paste it. You can copy and paste? I mean, with this, literally just click it, you bring it down, and then you instead of a plus, you turn it to a minus. Wait, which one?
If you're using a regular calculator, Ted, if you're using a regular calculator, you just calculate that. Okay. Then you calculate that. You add them together. Take the square root. Multiply.
Oh, you
subtract.
like breaking it down.
Yeah, that's all.
You said you can just pull it down. Can you just pull it down?
Oh, I don't know. I'm talking about if you don't have access to one of these calculators. You don't need this. It saves you time, but you don't need it. Okay.
You can just copy and paste it. No, I mean like what you said earlier. Okay, so if you put it in already, then you just highlight over it and then bring it down. I don't know how to do that.
He'll show you later.
I mean, I don't need to.
Okay, so which one are we going to choose? So go through the list.
Oh, two props, yeah.
So it's a two prop, right? So two prop Z, 5 and 6, no, because those are tests. There we go. Two prop Z interval. Slowly we're hitting all of them. We will hit all of them by the end of chapter 11. We will hit all of them. X1, what is X1?
39.
Which is what? Where'd you get 39 from?
That's P hat and the V.
The top, the numerator for P hat and V. Yep, 39. Good. The bottom is going to be 57. Good. X2 is 43. The numerator,
55.
the numerator of NP, P hat, NP, 55. It's a 99%. Calculate. Write it down.
Huh? Oh, yeah. I don't know what that means.
So let's see, negative 0.3114 to positive 0.11623. And we see that it gives us our p hat 1 and p hat 2, which we already knew. N1 and N2, which we already knew, right? Okay, so this is our proportion. This is our interval, right? You guys are just saying it has negatives in it. Why does it have negatives in it? There you go, right? These two p hats subtracted to each other is going to give us a negative, right? If I subtract these two guys here, see, I get negative 684 minus 0.782. This is going to give us negative 0.98. Okay, that's one of the reasons why it's negative. What's the other reason why it's negative? Well, let's do the conclusion. After the conclusion, it'll make more sense. All right, so conclusion. We are 99% confident that the true right here, that the true difference proportion, difference, we need that word in there, difference proportion. Difference proportion of what? What did we subtract? What did these two numbers up here that we subtracted based on, or what do they represent, I should say? The difference in the lower back patients who experience reduced back pain. The true difference proportion of lower back patients who experienced or who had reduced lower back pain is between negative 0.3114 and 0.11623. Done. So yeah. So what does that mean in plain English?
That the patient experience more back pain.
There is essentially no difference.
How do we know there's no difference between the two treatments, Josh?
Because it's between negative 0.3 and
Oh,
0.1.
zeros
It's
included.
zeros in the interval.
Zeros in the interval. So we don't have statistic evidence. Significant. We don't have. Where is it? Where was it? Where
I
was
think
it?
that's B.
We don't have.
We lack significant evidence to suggest. That's a big sample question.
We don't have significant evidence to say that the two treatments are different.
Oh, that sucks.
Right? We don't have, based off the data they showed us, there's not enough evidence to say they're different. Be careful though. I'll get students who say this. I'll get students who say, well, didn't these guys over here experience less back pain than these guys up here? Because these guys said 78% of them said they felt better. Only 68% of them said they felt better there. So that's 10%. Isn't that a difference? And I would say yes, it is a difference, but it's not significant. It's not significant enough to say to all people who have back pain, who experience lower back pain, that hey, we have a new treatment. If you do this instead of this, you will feel better, more better than the other way, right? It's not outside of chance. What they're saying is this difference here, these two, because these are just 55 people and 57 people. There's a lot more people that experience back pain. So what we're trying to do is say is it significant to say to everybody, to tell doctors, hey, doctors, stop giving your patients just naproxen. Give your patients naproxen and Valium. They will feel better, right? It's not enough. That's how doctors do it. When doctors decide what kind of medication to treat, right? During the pandemic, there was all types of things on how to treat coronavirus, how to treat COVID-19. You should try this. No, you should try this. No, you should try this. You should try this, right? And then you would hear doctors say, whoa, don't do that. Don't try that yet. Because they wanted this research to be done. And if they came up with a conclusion where zero was not in there, then they would go and say, okay, use this drug, it'll help. And that happens sometimes. There are some things they said that helped, but there are a lot of things that people were saying, it helps. And the doctors were like, whoa, I'm not saying no, but don't just go off of my friend down the street, right? My cousin used this and he got better like in a day, right? Don't do that. Let's do some research behind it and figure out if there's really something to it, right? Because if you're going to take some crazy medication that your cousin said works and you end up getting adverse effects to it, then you're up a creek. You make your problem worse, right? That's what kind of what this is. That's what they decide. So when doctors treat new things, they don't treat illnesses the same way they did back in the 50s, in the 60s, in the 70s. They have new methods, new prescriptions, new drugs. Well, how do they figure those out? Because these types of things are done. Okay? All right. Okay, so part B. Last thing we're going to do, part B. Last thing for today. Part B. We kind of just talked about this one. So answer the question. Answer the question. We'll talk about it in a few minutes. So based on the confidence interval that we just came up with, what conclusion would you make about whether Valium along with naproxen affects pain relief?
There is no statistical or there's no significant data to suggest that taking Valium along with naproxen affects pain relief as zero was included in the constructed interval.
Perfect. Just like that. Just like that. You want to say there's not statistically significant or there's not significant.
Statistically? Oh, okay. Yeah.
Whatever.
As long as
You want it to say significant. Yeah, significant is more important than statistic. Significant evidence, because people will look at this and say, "Hey, the naproxen or one is bigger than the other." Yeah, but it's not significant, right? It's my cousin down the street, as opposed to enough significant evidence. We've done research. We show that this causes this. And why? How can we say that? Because there you go. That's your justification right there. Your justification is because 0 is not within the interval. Okay, so you answered the first question by saying there's not enough evidence to say that that back pain will significantly improve because 0 is not in the interval.
So like, this is a 10-point question, right?
The one we just did?
Yeah.
If it was on a test?
Yeah.
No, it'd be 5, 6 points.
Really? I thought construct and interpret would be 7.
It's an interval. Intervals are 5 steps, 5 points.
And then this one's what, 2?
This one's a 2 or 3. This one right here, at least a 2 because there's 2 parts to it, right? Answer the question, justify. But I might throw a third point in there. Or usually when I make it worth 3 points and there's only 2 points, it's usually if you try, I give you 1 point. So really a 2 is a 1 and a 3 is a 2. But I usually make these 3 points because there's some people that are just way off, but they tried. So I want to give them at least a point.
And the participation point.
Yeah.
I'll take it. I'll take my point.
Okay. All right. Pretty much.
Yeah,
Pretty
no,
much
I
it's a pity
scratched
point.
off a point 'cause everyone goes-
There you go. It's pretty much it's a pity point. Okay. All right. We'll finish the rest or we'll continue tomorrow.